Welcome to Otisam Mathematics. I am on the series, the 7 building blocks of mathematics. Block 7, quadratic equation. I've made several videos on quadratic equation. In this video, I'm going to look at symmetric function. Before I look at symmetric function, I want us to consider the relationship between the coefficient and the roots of quadratic equation. If you have been following me, the general quadratic equation is of the form ax squared plus bx plus c is equal to 0, where a, b, and c are all constant. A is the leading coefficient. Okay. Now, if alpha and beta are the roots of equation, of quadratic equation, then forming the quadratic equation will be x minus alpha times x minus beta is equal to 0. So let's simplify. This implies that x squared minus beta x minus alpha x plus alpha beta is equal to 0. So we can write it as x squared minus alpha plus beta x plus alpha beta is equal to 0. So let me label this one as equation 1. And then let's compare it with the general quadratic equation, which is ax squared plus bx plus c is equal to 0. This is the standard quadratic equation. And to compare the two, let me name this one as equation 2. Now the coefficient here is 1, the coefficient here is a. So we need to divide through by a so that we can compare. So dividing each term of the standard equation by a. So this is over a, over a, over a, over a. So we have x squared plus b on a x plus c on a is equal to 0. So we can now compare the two. Now when you compare the two, we have minus alpha plus beta is equal to b on a. That is comparing coefficient of x. And then, which implies that alpha plus beta is equal to minus b on a. And then alpha beta is equal to, comparing the constant term, is c on a. So in summary, when you are given a quadratic equation, the sum of root, which is alpha plus beta, is equal to minus b on a. And then the product of root, which is alpha beta, is equal to c on a. Example: for quadratic equation 2x squared minus 4x plus 3 is equal to 0. Sum of roots, that is alpha plus beta, will be minus b on a. So before that, our a is equal to 2, our b, that's comparing this one with the standard equation, minus 4, and then c is equal to 3. So sum of root would then be minus 4 on 2, and which is 2. And then product of root that is alpha beta is equal to C on A, which is the same as C is 3, A is on 2. Alpha beta is 3 over 2. Symmetric functions. For symmetric functions, if you know the values of the sum of roots, which is alpha plus beta, and alpha beta, which is the product, we can calculate the values for other symmetric functions of the alpha and beta. So what is symmetric function? It is a function of alpha and beta in which if alpha and beta are interchanged or multiplied by minus 1, the function remains the same. For example, if you have alpha squared plus beta squared, when we interchange alpha and beta, we are going to get beta squared plus alpha squared, and which is the same as alpha squared plus beta squared. Okay. Now, if you have alpha squared minus beta squared, and we multiplied it by minus, look at this. So we are going to get, yes, we can get our function that is the same as alpha squared minus beta squared. So you look at this function, 3 alpha squared plus beta. This is not a symmetric function because when you interchange alpha and beta, you get a different result. Let's interchange it. So if you interchange alpha and beta, you are going to get 3 beta squared plus alpha, which is entirely different from this. And if you multiply through by negative 1, then you are going to get minus 3 alpha squared minus beta squared. So this function is not symmetric. So let's see how we are going to apply this. There are some useful expressions that we will need when we are simplifying symmetric function. Now I want you to be very careful here that if you have alpha squared plus beta squared, now it is the same as alpha plus beta all squared minus 2 alpha beta. Why this? This is because we can always get alpha plus beta from the quadratic equation given, which is the sum, and then alpha beta. So anytime you are given a symmetric function, you express them in terms of sum of root and product of root. So that is what this expression is all about, that you need to be familiar with, and then you also need to know how to come out with them. For example, the first one, let's look at this expression, alpha plus beta all squared. From expansion, it is alpha squared plus beta squared plus 2 alpha beta. So if you want this, you send this one to this side. So you have alpha plus beta all squared minus 2 alpha beta, which is alpha squared. So all the other expressions are based on this. So even if you don't know anything, make sure you know how to come out with this first expression. If you talk of the second one which is alpha minus beta all squared, and this is alpha squared plus beta squared minus 2 alpha beta. Now we know this one, so we just replace alpha squared plus beta squared with this expression, and we are going to get minus 4 alpha beta. So it will go on and on and on and on. So anytime you are given symmetric function, just express them in terms of alpha plus beta or alpha beta or both. So if you have alpha cube plus beta cube, this is the expression, and then alpha cube minus beta cube, this is also the expression. You are supposed to know them. And sometimes if you forget, that's what I've told you, go back to the root, you can come out with the expression, the formula for the expression. Let's look at how we are going to use these useful expression in finding evaluating symmetric function. Okay, our first example. Example 1. If alpha and beta are the roots of the quadratic equation 2x squared minus x minus 2 is equal to 0. Find the values of a, alpha squared plus beta squared, alpha minus beta. Okay, so this is the quadratic equation. 2x squared minus x minus 2 is equal to 0. First, let's compare it with the standard quadratic equation, which is ax squared plus bx plus c is equal to 0. Now when you do that, what is our a? A is 2, b is minus 1, and then c is minus 2. So, and then we find the sum of roots. Now we know that the sum of roots alpha plus beta is equal to minus b on a. So you just substitute minus 1 on 2, which is 1 on 2. And then alpha beta is equal to c on a, which is equal to minus 2 on 2. So you are going to get minus 1. So let's come to our symmetric function. We are to evaluate alpha squared plus beta squared. And from our useful expression, we said that alpha squared plus beta squared in terms of alpha plus beta and alpha beta is alpha plus beta all squared minus 2 alpha beta. So you just substitute these values. We know alpha plus beta, which happens to be the sum, is 1 on 2 all squared minus 2 times minus 1. So this is 1 on 4 minus 2 times minus 1 is 2. So we are getting 2 whole number 1 on 4. So that is the answer. Let's look at the next one. So alpha minus beta is equal to, from our expression, plus or minus square root of alpha plus beta all squared minus 4 alpha beta. So we just have to substitute the values. So plus or minus square root of alpha plus beta is 1 on 2 all squared minus 4 times minus 1. So this is the same as plus or minus square root of 1 on 4, and this time this will get plus 4. So this is the same as plus or minus square root of that's 4 whole number 1 on 4. And if you change it to improper fraction, you have plus or minus 4 times 4, 16, plus 1, 17. So square root of 17 on 4. Now by Z, we can split it, which is root 17 on root 4. So we are getting plus or minus root 17 on 2. Yes. So that is the answer. Okay, let's check other questions too. Still on the same quadratic equation. So look at question C and then D. I want you to pause the video, go through them, and then check it with the answer that I'm going to provide. C, we have to evaluate alpha squared minus beta squared based on the preamble that we have set. So the same quadratic equation, we know that alpha plus beta is 1 on 2, and then alpha beta, that is the product, is minus 1. So alpha squared minus beta squared, this is difference of two squares. And our motive is we always have to express the symmetric function in terms of either alpha plus beta or alpha beta or both. So this is difference of 2 squared, and under difference of 2 squared you can write this one as alpha plus beta and then alpha minus beta. We are fortunate, we have found alpha minus beta. We know this one, alpha plus beta, so we just substitute them. So 1 on 2 times, from our previous question, alpha minus beta was plus or minus square root of 17 on 2. So we have plus or minus root 17 over 4. Okay, let's look at the p part. 1 over alpha plus 1 over beta. Now this is a fraction, and for every fraction you find the LCM. So let's find the LCM. LCM of alpha beta is alpha beta. So this will go here, beta times 1, then alpha. So we have alpha plus beta over alpha beta. So we substitute them. Alpha plus beta is 1 on 2. Then alpha beta is minus 1. So we are going to get minus 1 on 2. Okay. So the next thing that we want to look at is sometimes you'll be given the symmetric function and then you'll be asked to find or form the new quadratic equation. First of all, we need to find alpha plus beta and alpha beta. Given equation is 3x squared plus 5x minus 1 is equal to 0. So comparing this one with the standard equation, ax squared plus bx plus c is equal to 0. We have our a to be 3, b to be 5, and then c to be minus 1. In that case, we first find the sum of roots. So sum of roots will now be, the new root is 5 alpha plus 5 beta. So 5 is common, we factorize it out, alpha plus beta. So alpha plus beta is minus b on a, which is minus 5 on 3. And then alpha beta is c on a, which is minus 1 on 3. So our sum of roots now becomes 5 times alpha plus beta is minus 5 on 3, minus 25 over 3. So let's look at the product of roots. Product of roots becomes 5 alpha times 5 beta. 5 times 5 is 25. Then we have alpha beta. So alpha beta is minus 1 on 3. So 25 times minus 1 on 3, which is minus 25 over 3. So we just substitute it in the equation. It said that x squared minus sum of roots, new root x plus product of roots is equal to 0. So x squared minus, you have minus 25 on 3 plus minus 25 on 3. So this will be x squared plus 25 on 3 minus 25 x. You have to bring out your x equal to 0. You multiply through by 3, so 3x squared plus 25x minus 25 will be equal to 0. So that is the new equation. Let's look at the second one. The roots are alpha squared and then beta squared. So we first have to find sum of roots, which is alpha squared plus beta squared. And from the expression that we look at, this is the same as alpha plus beta all squared minus 2 alpha beta. So alpha plus beta, what is alpha plus beta? Is minus 5 on 3 all squared minus 2 times this, which is minus 1 on 3. So you have 25 on 9 minus times minus giving us 2 on 3. So the LCM becomes 9, and this will be 25. 3 into 9, 33 times 2, 6. So we have 31 on 9. So product of roots, this is alpha squared times beta squared, and this will be alpha beta all squared. So you are getting minus 1 on 3 all squared. So you have 1 on 9. So let's form the equation. So x squared minus sum of roots x plus product of roots is equal to 0. So our x squared minus sum of roots, we had 31 on 9 x plus product of roots is 1 on 9, which is equal to 0. So as usual, you multiply through by the LCM. So we have 9x squared minus 31x plus 1 is equal to 0. That is our new equation. Still on the same preamble, we are to find the equation when these are the roots of the equation. Alpha plus alpha 1 over beta and beta plus 1 over alpha. So we are using the same equation. You know alpha plus beta equal to minus 5 on 3, and then alpha beta equal to minus 1 on. So let's look at the sum. So sum will be alpha plus 1 over beta plus beta plus 1 over alpha. Remember, always you are expressing the symmetric function in terms of alpha plus beta and alpha beta. So let's rearrange. We have alpha plus beta and then 1 over beta plus 1 over alpha. Now this is alpha plus beta. This one, when you simplify, you get alpha plus beta on alpha beta. So we have minus 5 on 3 plus minus 5 on 3 on minus 1 on 3. Now this, so you have minus 5 on 3 times 3 gets 5. So you have minus 5 on 3 plus 5. So the LCM is 3 minus 5 plus 15, which is 10 on 3. Let's look at the product of root. So alpha plus 1 over beta times beta plus 1 over alpha. So this is, you multiply this, you have alpha beta plus 1 plus another 1 plus 1 over alpha beta. So this is alpha beta plus 1 over alpha beta plus 2. So alpha beta is minus 1 on 3 plus 1 over minus 1 on 3 plus 2. So 1 on 1 times minus 3 over 1. So here we have minus 1/3 minus 3 plus 2, which is minus 1/3 minus 1, which is equal to minus 4 on 3 when you simplify. Then form the equation. So we have x squared minus 10 on 3x plus minus 4 on 3 is equal to 0. Multiply through by the LCM, which is 3x squared minus 10x minus 4 is equal to 0. Viewers, thank you very much for watching this video. If you have not subscribed, kindly click on the subscribe button for more of these